and want to see how neural networks can be trained to solve problems in these spaces, I think you'll enjoy this book. And if you have models that you've trained and want to get them into the hands of users on mobile, in the browser, or via the cloud, then this book is also for you. Most of all, if you've been putting off entering this valuable area of computer science because of perceived difficulty, in particular believing that you'll need to dust off your old calculus books, then fear not. This book takes a code-first approach that shows you just how easy it is to get started in the world of machine learning and artificial intelligence using Python and TensorFlow. Why I wrote this book. I first got seriously involved with artificial intelligence in the spring of 1992. A freshly minted physics graduate living in London in the midst of a terrible recession, I had been unemployed for 6 months. The British government started a program to train 20 people in AI technology and put out a call for applicants. I was the first participant selected. 3 months later, the program failed miserably, because while there was plenty of theoretical work that could be done with AI, there was no easy way to do it practically. One could write simple inference in a language called Prolog and perform list processing in a language called Lisp, but there was no clear path to deploying them in industry. The famous AI winter followed. Then, in 2016, while I was working at Google on a product called Firebase, the company offered machine learning training to all engineers. I sat in a room with a number of other people and listened to lectures about calculus and gradient descent. I couldn't quite match this to a practical implementation of ML, and I was suddenly transported back to 1992. I brought feedback about this and about how we should educate people in ML to the TensorFlow team, and they hired me in 2017. With the release of TensorFlow 2.0 in 2018, and in particular the emphasis on high-level APIs that made it easy for developers to get started, I realized the need was there for a book that took advantage of this and widened access to ML so that it wasn't just for mathematicians or PhDs anymore. I believe that more people using this technology and deploying it to end users will lead to an explosion in AI and ML that will prevent another AI winter and change the world very much for the better. I'm already seeing the impact of this, from the work done by Google on diabetic retinopathy, through Penn State University and Plant Village building an ML model for mobile that helps farmers diagnose cassava disease. Médecins Sans Frontières, using TensorFlow models to help diagnose antibiotic resistance, and much, much more. Navigating this book. This book is written in 2 main parts. Part 1, chapters 1 through 11, talks about how to use TensorFlow to build machine learning models for a variety of scenarios. It takes you from first principles, building a model with a neural network containing only one neuron, through computer vision, natural language processing, and sequence modeling. Part 2, chapters 12 through 20, then walks you through scenarios for putting your models in people's hands on Android and iOS, in browsers with JavaScript, and serving via the cloud. Most chapters are standalone, so you can drop in and learn something new. Or, of course, you could just listen to the book cover to cover. Technology you need to understand. The goal of the first half of the book is to help you learn how to use TensorFlow to build models with a variety of architectures. The only real prerequisite to this is understanding Python, and in particular, Python notation for data and array processing. You might also want to explore NumPy, a Python library for numeric calculations. If you have no familiarity with these, they are quite easy to learn, and you can probably pick up what you need as you go along, although some of the array notation might be a bit hard to grasp. For the second half of the book,